All right, so this is going to be a video about domain and range. Now, domain is just a fancy word for all possible x values, while range is a not so fancy word for all possible y values. Okay, now these x values are related to these y values. So these are actually going to be all possible x values and y values for relations as well as functions. Okay, so let's look at some examples to kind of cement our understanding of what domain and range is really all about. Okay, so we have number one right here, and it's basically a set of ordered pairs. So this right here represents a relation. And these ordered pairs we have xy, 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 xy. So we have a bunch of ordered pairs that represent this set, and a problem might be find the domain and range for this set of ordered pairs. Now, domain is all possible x values. So what you would need to do for the domain is find all the possible x values that are in each of these ordered pairs. So if you look here, we got 0, we got 3, -3, and 1. So all we really need to do is write for the domain 0, 3, -3, and 1. It's literally that simple. Okay, you need to put a little curly brace because that's just the standard notation for writing this. And you would write 0, 3, -3, 1, and then an end curly brace just like that, and then we have the domain. Now the range is all possible y values, as it says right up here. So you would need to do the exact same thing that we just did for domain, only for the y values. So we have 2, 4, -2, and then another 4. So we have to write that down again in curly braces separated by commas. So we have 2, we have 4, we have -2, I'm sorry, and 4 again, and then ends curly brace, and we have the possible y values right here for the range. Now, the same problem, the teacher might be asking you a question like, does this represent a function? Does this relation represent a function? Now, if you remember from the last video, a function is a relation where every single x value only has one possible y value. So if you input a 2, you're always going to get a certain value out, and it's always that same value each time. So for this, does this represent a function? Well, every single domain right here, 0, 3, -3, and 1, there's not even any repeats to show if this is a possible function or not. So really, in that case, it actually is a function because it doesn't have any possibilities where there's an x and it outputs a different value for that x. So this would be considered a function. Okay, number 2. So we have this graph right here. And if you remember, these ordered pairs can be graphed, just like on this graph right here, to represent that graph. So you have the x-axis and the y-axis. If you plot all the points in between, it makes this graph. Okay, so the domain, it's all possible x values. So all possible x values in this graph, well, the smallest possible x value that we can start with is over here at -2. So what I'm going to do is actually write that down first for my domain. So I'm going to write -2. And the biggest possible x value that I can go, so the furthest that I can go to the right is 3. Okay, we're just looking at the x-axis here, is 3. Now, if you notice, it's not included because it's an open circle. This open circle means you can't actually include that value in the domain. This closed circle means you can include that -2. So we have a -2 in our domain, and it's less than or equal to x, again, because the domain is all the x values. So it's less than or equal to x, which is less than 3, but not actually including 3. So it's not less than or equal to 3, it's just less than 3. So the possible x value, so it's this -2 to the +3 right here. This is basically writing that right here. So it's basically saying that x is between -2 and 3. Those are the possible x values that you can use for this particular graph right here to find the domain. Okay, the range, you would do the exact same thing, only this time we're going vertical on this. So we're only looking at the y values. So the smallest y value that we have is -3. So I'm going to write -3 in there. Now it's included in that actual range. So we're going to do less than or equal to, less than or equal to y. And then the biggest that we can get right here is 4. So it's -3 down here, but 1, 2, 3, 4 up here. And you're not actually including that 4 because it's an open circle. So you'd say -3 is less than or equal to y, which is less than 4. Okay, so that's how you find the domain and range when you see a graph that's not continuous throughout all the numbers. So it stops here and it stops here. All right, so one thing I want to explain before moving on to the next problem is this right here. You can actually write this in a different kind of notation. It's called interval notation. Now, what you can do is basically the biggest and the smallest for this domain would be -2 and 3. You can write these separated by commas, so -2, 3, so -2 and 3, just like that. And on the end, if you want to, So at the ends of either of these, you have to actually write either a parentheses or a bracket. Now the parentheses or a bracket both mean different things. So in this case, you see how it's less than or equal to? You would want to actually include a bracket over here because it's including that -2 in the domain. This 3 is not included, okay? Because remember, you can't actually include it because it's this open circle. So you would actually have to put a little parentheses like that. So this is another way of writing this right here. So these are actually the same thing. So you can actually write either way. Some of the problems might say write it in interval notation, and then you would have to write it using this interval notation way versus this compound inequality. Okay, we're going to do the same thing for this range here. Now, it's -3, which is the smallest, so we're going to write -3, 4. Now, the -3 is included, so I'm going to put a bracket around that -3, and then the 4 is not included, so we're going to do a parentheses like this. Now, it is possible to have double parentheses here if it was like less than, and there was no or equal to, less than or equal to, it was just less than and less than, you could do double parentheses. Or if this was less than or equal to, it could be double brackets. It really depends on the problem. Just for this example, that's kind of what it looks like. So I just kind of want to throw that in there. We're going to do the same thing with the next problem here too as well. Now let's look at a graph that's continuous throughout all numbers for x here. So in this case, we have this quadratic function right here. And if you notice, it's got arrows on the end. This one does not have arrows, okay? So it stops, basically. It's continuous within this domain, within this interval right here, but it's not continuous everywhere. Or here, it's going to be continuous on every single possible x because of these arrows. It means it's going up and to the right forever. This one means it's going up and to the left forever. Okay, so the possible domains here, now we're only focused on the x for this. Now, since I said it goes up and to the right, it's going to the right forever, basically. Okay, so I'm actually going to write that down for the domain. So it's going to the right forever. Here, this arrow here is also showing that it goes to the left forever. So that means it's going to the right forever and to the left forever. So the way you would write this for the domain is you could write it as -infinity is less than x, which is less than positive infinity, okay? So it's basically saying that x is between -infinity and positive infinity. So it can be greater than -infinity, so it can go this way, and then it's less than -infinity, or less than infinity, so it's going the other way. So that's basically how you would write that. You could also write it with set notation if you wanted. So let me get rid of this r right here. You could also write it like this, where it's -infinity, infinity. We're going to talk about, whoops. We're going to talk about this notation a little bit later in the class, okay? So that's the domain for this function. The range is all possible y values. If you remember, it says it right here, all possible y values. So let's start with the smallest possible y value that you can get. So we're going to go as far down as we can go and still staying on the graph. The smallest that we can go is this -3. So it's 1, 2, 3. The smallest we can go is -3, so I'm going to write -3 in here. And that's going to be less than or equal to y, because it's included. And then the biggest y that we can get, so how far up can we go? Well, this is going up forever. You see it's going up forever. So that means this y is basically going to infinity. So I'm going to write less than infinity here. So that's how you can write that. Or you can write it with interval notation if you wanted. You can write -3. You'd have to actually do a closed bracket here, okay? Because it's including that -3, infinity, and then you can never actually get to infinity, so you always have to do this open interval, just similar to what we did for the domain right here. So that's basically a video explaining what domain and range is, and kind of some example problems to kind of cement your understanding of what it means to find the domain and range for a function or for a relation. So if you have any questions about anything in this video, let me know.